But there we have it, a sustainable house. And I think when most people think about, okay, what is that, what's that house going to look like? You usually think about some of the things that are fairly obvious. We got a wind turbine that is connected to the house. So there's this main electrical service panel. You know how you usually have all your breakers that are loads? One of the breakers is the wind turbine, and energy goes in through that breaker rather than energy coming out. Got the wind turbine. Then there is two solar hot water systems. One of them is a flat plate collector over there on the lower roof. And the other one is entirely buried in snow over here, which is the evacuated tubes. We'll talk a bit more about those and why those ones are buried and why the other one is clear. A little counterintuitive thing. Evacuated tubes actually perform better in the cold. Then up on the roof, you can see I've got there's a bit of construction going on there. That's a new BIPV, so Building Integrated Photovoltaic. So you can see there's no roofing there, right? The blue steel roof is missing. You can also see a blue tarp down on the ground here, just behind that sign. That's our old BIPV system. It was installed for 5 years, and it started delaminating. So all the different layers that are made, that the module is made out of, started coming unstuck. Yeah. That can be a bad thing, especially if they come unstuck out at the edge. Moisture can get in there, and the voltage can leak out. The system runs at about 300 volts, so it's not a good situation.
Yeah.
So, as much as putting PV modules in the roof, we're displacing another building material, so it's more cost effective, especially in the long run. PV modules typically, we've got some, you'll see some later, that are 28 years old and still within 5% of their original manufacturer nameplate. They can last that long. These ones failed after 5 years, manufacturer defect. They weren't, they weren't making the lamination hot enough when they pulled the vacuum on it, and it didn't stick together properly. Typically, I would, of all the modules that I've seen here, and I bought my first photovoltaic module in '78, built my first hot water system in '76. So in all that time, maybe 1% of modules I've seen have had a problem. It's a very robust technology normally. You go and put it in a roof, and what do you know? It screws up. So now I've got something that is the cladding for the building that's messed up, and it's a much more onerous process then to remove them and put new ones in place. Whereas usually what you'll see over there is modules racked over an existing roof. The thing is, most roofs in residential are asphalt shingles that maybe have a 10-year life cycle. So what you do is you put up the array over the roof. The roof wears out. You got to take the array down, redo the roof, put the array back up. Another 15 years goes by, array comes down, roof goes up, array goes back up. So that's where you can see it's kind of compelling then to build them into the building. But then if you have a problem like we did here, it's a bigger problem, because if they were just on a rack, I just pulled them off the rack, put new modules on the rack. This way I gotta expose the roof of the building, and now we got to re-flash all around the outside of that. The other system there's a black panel on the back end, just above the garage here. That's a solar hot air panel. You can kind of see there's kind of a top section and a bottom section. The top piece is a PV module, so it's making electricity from sunshine. That's to drive the fan. The bottom part is just a sheet of glass and an absorber. The light is coming through the glass and it's hitting the absorber up, and there's two ducts with little doors on them. So right now the sun is shining on it, the fan is running. When the sun goes down, no more sunshine, no more energy, no more heat. It turns itself off. So it doesn't actually have control. There is a thermostat on it in case the room gets too hot. But other than that, the system has modulating control all on its own. So if you can match the photovoltaics energy that way to the solar thermal system is kind of a nice way of doing control. We're working on there's a 2-acre field over here that's gonna grow vegetables in. And we're gonna do the same thing there using photovoltaics to pump water. If it's hot and sunny, the plants need water. There's energy to pump the water. If it's overcast and rainy, the pump can't run, but that's okay because you don't need it. So whenever you're looking at renewable energy, it's always nice to find a load and a resource that are concurrent. A cottage used in the summertime, photovoltaics works very well. I use the cottage in the summer
For
there's lots of
HVAC.
sunshine.
Yes?
Sorry?
For HVAC during the summer, for example. To cool down for air conditioning.
Yeah, you have the resource at the same
And you
time.
need it.
You know, as the load. The opposite of that would be a ski chalet, right? You use it, but you have very short days in the winter time. And another example is outdoor lighting. We have very long nights in the winter, and you want the light on a lot, but there's hardly any resource. So that's the opposite end of the spectrum. So when you're looking at renewables, whenever you find a load that's concurrent with the resource, that's going to be one of the first places, whatever technology it is going to be adapted to.